This is a brief demonstration of GSE Systems PSA HD, where we are utilizing a model of Fukushima units 1F1, 1F2, and 1F3. Here is a photo showing how this is actually set up. The three large monitors are showing units 1F1, 1F2, and 1F3 from left to right. The smaller monitor in the foreground is for the user to control the scenario. The compilation of video clips shown in this demo are of the first 60 hours out of a total of 120 hours of our Fukushima plant scenario. As we continue through this demo, you will hear voice descriptions of the powerful features of GSE's PSA HD tool. As you can see now, units 1F1, 1F2, and 1F3 are running simultaneously. Users can see events unfolding in each of these three units across three monitors in chronological order. It is difficult to make out the details in this clip, but as you saw just a moment ago, each unit normally has a monitor dedicated to it. We will take a detailed look at the Unit 1F1 screens shortly. First, let me give you a brief overview of the events that occurred at Fukushima. For Unit 1F1, the core is uncovered and starts to fail at about 4 hours. At 8 hours, the failed core falls down to the lower head. At 11 hours, the lower head fails and the core relocates to the containment sump. After almost 24 hours, venting from the stack took place to relieve the containment pressure. The scenarios in Unit 2 and 3 are quite different. These cores did not fail completely because they were submerged. However, you may see some venting took place in Unit 1F3 after roughly 42 hours to relieve containment pressure. Although not shown in this video, users of PSA HD may pause and replay the simulation. Users can also insert an external event or response to perform what-if analysis. Users may also save and return back to previous scenario points. Results can be recorded and exported for further study. Here you see a summary of Unit 1. The top two drawings show the containment building and core state. On the bottom, our JDB tool is running three trends. Now we'll take a closer look at only the core state drawing. The middle of the reactor vessel shows the fuel channels. Each channel is divided into nodes to match the map model output. Clicking on any node will pop up detailed temperature information for that node. In addition to seeing specific temperatures via the pop-up window, it is also possible to get an overall sense of the temperature distributions using the color spectrum. The color spectrum can be adjusted on the fly to better match the current state of the model. In this case, I will adjust the maximum temperature down to 4,000 degrees. You'll see that the nodes update automatically. The same thing can be done independently for each of the other display choices on the left side. As the event proceeds, I'd like to point out the clock showing local Japanese time near the upper right corner. There is also a timer counting up that marks time since the event started. Both are true to reality. When the fuel relocates to the bottom of the vessel, we will go back to the summary and speed things up. Our JDB tool can run the model in fast mode, which can be as fast as 2 minutes of simulator time per second of real time. I have further sped up the video playback rate for brevity's sake. To show the failure of the vessel lower head and relocation of core materials, I removed all playback rate enhancements. Now we'll take a closer look at the containment building drawing. We've skipped ahead in time because the rupture disk is close to opening to vent out the stack. The nodalization of the map model was again used to craft the graphic icons. You can see as I mouse over the different nodes that a tooltip shows the current value of the selected property in the node that I am pointing to. If I click on a given node, the hydrogen flammability triangle will update to represent that node, and a description below the triangle will update to show which node has been selected for viewing. As I change to different properties, the tooltip also changes the displayed property to match the current selection. Just like the core state drawing, there are multiple map model properties that can be displayed, and the color spectrum is still adjustable. You'll also see small, blinking puffs of gas to show how gas is moving between the nodes, and blue arrows to show the movement of liquid. Hovering over either of these, or the rupture disk leading to the stack, will provide a tooltip showing the flow rate. Now I'll briefly click through all of the available property choices in this drawing, showing the tooltip display for a few nodes on each property selection. I'll also continue to click on nodes to update the flammability widget and its description. The remainder of this video will show units 1F2 and 1F3 simultaneously through the remainder of the first 60 hours.